When it comes to word problems with derivatives, it's important to understand what they're asking and what a derivative really is. This is a multi-part problem from a book, and it says here the consumer price index is described by the function I of t equals negative 0.2 t cubed plus 3t squared plus 100. So it gives us a function that represents the consumer price index. One of the questions it asks us about this is what is the average rate of increase from 2005 to 2010? And it says here that the year 2000 is when t is equal to 0. So before we do anything, it's important to understand what they're asking. So we're going to start by drawing a function. We're going to oddball this one and just sort of pretend that this looks like something here. So let's say the function looks like that. And that is the function I of t. So we're going to say that this graphs into this. I know it doesn't, but it's for theoretical purposes. So this is the y-axis, or I of t. And this is the x-axis, which would be t in this case, because it is the letter t corresponding to time. So if t0 is 2000, and this would be the year 2000, so that's t0, and let's say 2005 is right here at t5, and 2010 is t10 here. So here's our x values that correspond with our y values. So if we draw a line up, we'll see that that corresponds with that point there, and at t equals 5, it corresponds with this point here. So when it's asking us for the average rate of change, that simply means the average rate of increase from 2005 to 2010 is basically the slope between these 2 points right here. Slope is the average rate of change. So basically I drew a line there connecting these points because when it asks for the average rate of change, it's referring to the change in y over the change in x, which is slope. So using that information, we know what y is and we know what x is. So we're simply going to go through the drawn out process of finding the slope with t equals to 5 there and t equals 10 there. So using that information, let's get rid of this diagram and find our change in y over our change in x. Notice we are not taking a derivative here. We're not asked to find the instantaneous rate of change at a specific point in time. We are asked to find the change over a period of time, which is slope, the average rate of change. So the change in y, as we know, I of t is y and t is x. So using that information, the change in y is going to be y2 minus y1 over x2 minus x1. That is slope. So using that information, let's plug in what we have. y2 is going to be I of 10. Because remember, t2 is 10. Minus I of 5, which is t5, over x2, which is 10, minus x1, which is 5. And that is our overall formula for finding the slope to this problem. So when we plug in what we have here, we know the denominator is going to be 10 minus 5, which is 5. I of 10, we are simply, in place of t, plugging in 10. So we have negative 0.2 10 cubed plus 3 times 10 squared plus 100. That is I10 minus, and room is going to be a premium here, the same thing but with 5. And remember to put it in parentheses because the subtraction applies to everything. Negative 0.2 t cubed, which is going to be 5 cubed plus 3 times 5 squared plus 100. Alright. So there we go. I of 10 minus I of 5 over 10 minus 5. So we have some more work to do here. So let's simplify by distributing the minus, and hopefully things will cancel. We have a negative 0.2, 10 cubed, which is 1,000. So I'm going to go ahead and write that. 10 cubed is 1,000. Plus 3 times 10 squared, which is 100. Plus 100. Minus, distributing the minus sign now. Changing the sign of that so that becomes plus 0.2 times 5 cubed, which is 125. Minus 3 times 5 squared, which is 25, plus, minus, because of the minus sign we're distributing, 100. All over 5. Okay, so we've eliminated our parentheses, so now we have just some terms here that we can probably combine. Here we have a minus 100 and a plus 100, so those are gone. And that's probably going to do it. So at this point, if you want some help of a calculator, feel free to do that. 0.2 times 1,000 is going to be 200. And don't forget the minus sign there, negative 200. Plus 3 times 100 is 300. Plus 0.2 times 125 is 25. Right there. Minus 3 times 25, which is 75. All over 5. All we're doing is simplifying here. At this point, we'll just continue to simplify. Negative 200 plus 300 is 100, plus 25 is 125, minus 75 is 50. 50 over 5, which reduces down, canceling common factors of 5 times 10 over 5. 5's cancel, so you're left with 10. So, the average rate of increase from 2005 to 2010 is 10. 10 CPI. So that is the average rate of increase. Next, we will determine the instantaneous rate of change, which involves finding the derivative. So the next step of this problem, it asks us, at what rate was the CPI changing at 2005? This is not asking for a rate of change over a period of time. It's asking us specifically how fast or how much it was changing at that particular instant in time, 2005, which, as we know, is equal to t equals 5. So remember last time we found the rate of change over a period of time from 2010 to 2005, so we found the slope of this line. In this case, we're only worried about the slope at t equals 5, this point right here. So what we're going to do is basically find a tangent line that only touches at that point. Here, when we find the slope of this, aka the derivative dy over dx, that is going to give us the instantaneous rate of change. Remember, anytime in a problem where it asks for a rate of change of any kind at just one moment in time, you're going to be taking the derivative. So, instead of using the original function like we did last time, we're going to change it up and we're going to have to find the derivative. So, since we're required to find the derivative here, I prime of t is going to be just simple use of the power rule. So the first term here, we have a negative stays put, power comes down, 3 times, let's not forget the 0.2. Well, let me rewrite that. That's a little confusing. The negative 0.2 is a constant and it stays put. Now let's do the power rule to the t cubed, which is going to be 3t squared. Okay. Plus 2 comes down to the 3. 3 times 2 is 6t. And that's it. Derivative of a constant, aka 100, is 0. So this is the derivative here. Simplifying this, we get .2 times 3 is going to be .6, so negative 0.6 t squared plus 6t. And that is going to be the derivative, I prime t. So we found the derivative, and it says at what rate was it changing at 2005, which we know to be t equals 5. All we're doing here is plugging in 5 into our derivative, I prime of 5, which is just like this, 0.65 squared plus 6 times 5, which gives us 5 squared. Remember, order of operations, your power always comes first. 5 squared is 25, so you have a negative 0.6 times 25 plus 6 times 5, which is 30. So I'm going to cheat here and use my calculator. We have a .6 times 25, which is 15, plus 30, which is 45. So we have a, well, let's see here. Negative 15 plus 30 is going to give us 15. So that is the rate at which the CPI is changing at that instant, at 2005. Remember, derivatives are for instantaneous rates of change. Other than that, you're just going to use the slope, the change in y over change in x, or the average rate of change.